It's Friday.
Check the side pocket of your back.
My notes are 4-7.
Okay, 4-7. Shh. Talking about overlapping triangles. That means that they have something in common, or that they cross each other. I feel like we all know what overlapping is. So our objective to identify congruent corresponding parts and to prove two overlapping triangles are congruent. So, first thing we're going to talk about is what are two triangles have in common. Okay? In this case, I'm looking at triangle ABD. This red triangle and triangle DCA, which is this green triangle. So what side is both red and green? AD. So that's the side they have in common. Sound simple enough? No.
I'm just kidding.
So is this like a theorem or is it?
Is this
No, it's just another way, like if I asked you to prove triangles congruent, if they're overlapping. When they share stuff and we do proofs, what do we use a lot? If they share something.
That equals itself.
That it equals itself, yeah, which is what?
reflexive.
Reflexive. See, you guys already got 90% of this down. Okay, this says to separate and redraw the indicated triangles. So that's what we're going to do. This triangle BEC, that is this triangle right here. So we got BEC. Draw them.
To redraw it.
Yes, redraw them.
It's gonna look like nothing.
That's okay. And then triangle BDF. Is that triangle there? Yes, it says separate. Draw. They're just two triangles.
That's very fun. Just like the same things.
Right. So after we separate and redraw them, it says identify any common angle of their sides. Well, what do these two triangles have in common?
Angle B. Yeah.
Angle B, yeah, B. This right here, right? Do they share a whole other side?
No.
No, they share parts. We just care about whole sides. So all they share totally is that top angle B. Okay? Questions there? Alright, let's separate and draw here. We got GLJ. This triangle GLJ. And this triangle HJL. Yeah, what's up?
Sorry. For A, couldn't you say triangle BED has the same side as triangle BEC because they both share side BD?
Yeah, but we don't have triangle BED. We have triangle BDF.
They have the entire triangle.
Right, but the triangles that we're talking about are these two. BDF and BEC. Yeah, if it asks about BED, then you can say the share. Yeah.
Okay.
Okay, on B, what do those two triangles share? Yeah, side LJ or JL. Do they share any angles? So here, angle L is like, I don't know, let's say 45 degrees. What's this angle L? It's like 90.
You can't assume.
So can I say that they're the same?
You can't assume my angles.
Well, I said it's like. All I know is that they're not the same. The only thing they share and the only thing that's the same is that whole side LJ. Okay, questions?
No.
Okay, let's get on to the proof part. Alright. Says I'm given a couple things and I want to prove BEC is congruent to BDF. When we have overlapping triangles, we are going to separate our triangles that we're trying to prove. so that it makes life easier. Okay? So we're gonna draw triangle BEC. Separate them and BDF. Okay, because if you try to mark on that other triangle, it's gonna look messy and you don't even know what you have. Promise that. Okay. First thing we're gonna write in our statements is what? The given part, which is what?
BF equals BC.
BF is congruent to BC, and mark it in your drawing. Oh, I forgot my reason. What else can I say?
B equals B.
What?
Angle B equals B.
Angle BEC is congruent to BDF.
Yeah, let's do that one first. Angle BEC is congruent to angle BDF. And I know that because why? Yeah, man. And we'll mark that one as well. Okay. With overlapping triangles, we always try to find what they have in common. Riley, what do they have in common?
B.
Angle B, yeah. This angle, oh boy, up there. And they share it. When they share it, we just say it's congruent to itself. So we're going to say angle B is congruent to angle B. Why can I say that? Reflexive, good.
I thought we're not allowed to write angles like that.
What?
I thought we're not allowed to write angles like that.
When it's only one obvious, like the only angle B is that one up there. Like down here you can't say angle E because it could be this big angle, it could be this small angle, it could be that small angle. But there's only one angle B, right?
Okay.
Does that make sense? Okay. Alright, and then we'll mark it here in our smaller triangles. Okay, I'm trying to prove that my two red triangles are congruent. Can I say they're congruent?
Yeah.
Why?
And the vertical angle theorem.
Triangles are congruent because of our 5 things, used to be 4. How many sides do I have?
3.
1. How many pair of sides that are congruent?
1.
1. How many pairs of angles?
SAA.
Is there such thing as SAA?
No.
What's it called?
SA.
What?
AAS.
No,
ASA. No, ASA means our side has to be in between.
Side
SAS.
We got
SAS.
angle, angle, side.
Danielle said that. Yeah.
I know she did, but Maddie just had to talk over her. So I can prove that my two triangles are congruent by AAS. Okay, questions there?
Happy to make it.
We need double the homework to do this thing.
That's why we don't give our ideas.
Alright. Does it tell me what triangles I'm trying to prove?
Probably.
No. But it does say angle ABC. So I'm probably talking this triangle and this triangle. So let's redraw those. We got ACD and CDB.
So we don't have to have like the
That's the HL theorems only when we have a right triangle. Okay, ready?
Yes.
What's the first thing I can say?
is congruent to BC.
Why?
Given.
And mark it. AD, BC.
Angle ADC is congruent to angle BCD.
Why?
Given.
Mark it in your picture ADC
CD.
and BCD. Okay, when we have overlapping triangles, they have to share something. What do they share?
CD.
Say what?
CD.
CD. That's a line, right? So what should I say?
CD is congruent to CD.
CD is congruent to CD, because what?
So
Good. And mark it.
how do you do the triangle?
What?
How would you do the triangle?
SAS
Yes.
congruency.
Yep, I can say my triangles are congruent by SAS. So triangle ACD is congruent to triangle BDC.
ACDC.
Not ACDC, no. By SAS congruency. Is that what I want to prove? No. I want to prove that AC is congruent to BD. Well, my triangles are congruent. So what does that mean?
They're congruent.
That those two sides are congruent. Why?
Because it says so.
If my triangles are congruent, and then we go to sides and angles,
That's the same thing.
that C thing. CP, CTC. When you go from triangles to angles or sides, it's always that C thing. CPC, PC. Okay. Questions there?
You call it a day and not do what?
No questions?
Yeah.
Okay, this last one, bear with me. It is probably the longest one we've done, but it's not bad. Do you see two triangles that share something? They share BD? AD. So let's draw the two triangles that share AD. So we have one that goes kind of like this, where we have A, D, and C. And then we have the one that kind of goes like this, where it's A, D, and E. If you didn't know what triangles to start with the given stuff. I'm given angle CAD, so it had to be this triangle, because that's what angle I'm talking about, okay? So we'll start with our given. Angle CAD is congruent to angle EAD, because it is given.
Angle C is congruent to angle E because it's given.
Good. Angle C is congruent to angle E because it is given. And this is the same kind of thing. There's only one angle C, only one angle E. That's why we can just say C and E. When we're out of given, what should our next step be? Look for something that's what?
They're sharing.
That's shared. That's the same. What are they sharing?
Sharing
AD.
AD. Yeah. So what do I say? AD is congruent to AD. And why? Reflexive, yes.
Sweet.
So the thing that we just learned today is basically why a reflexive is reflexive.
Say that again.
What we're learning, or whatever, this was the as congruency, you know, like the overlapping thing.
Mhm.
That's just reflexive, right? That's basically
Kind of.
what it is.
When they overlap, they share something. When they share it, it's reflexive. So kind of it's reflexive, yeah. Alright, what can I say about my triangles? If I start here, I have
Angle
side or an
side.
angle.
SAS congruency.
I have two sides.
I mean, AAS congruency.
AAS. So I can say triangle CAD is congruent to triangle EAD by AAS congruency.
But that's not what we're trying to
Right. It's not. What my goal is to prove that BD is congruent to DF, those two green things. Okay. So what if we made more triangles? Because those triangles aren't in our triangles we already have, right?
CDB and
Yeah. So we have triangle BCD and triangle FED.
Two triangles.
Yeah, I promise that's it. Well, we already know something about these triangles. I know this number 2, C and E. Those are in here, right? I already know C and E are congruent. Okay? If these triangles are congruent, these ones, if they're congruent, everything inside them has to be congruent, right? Well, so does that mean CD and DE are congruent? Which is here and here? Yeah, why are they congruent?
Because we see
If I go from triangles to CD is congruent to DE, what's that called?
The C, whatever. that
Yeah,
is.
the C thing. CPCTC. So in this triangle, I have my angle. I now have my side. You look at their big picture here. What else do we know? What about D? It's not a midpoint. What about our angles?
Isn't like
Vertical
they
angle.
share?
They're vertical, yeah. So if they're vertical, they're what? Congruent. So aren't these two angles vertical?
C.
So we say angle BDC is congruent to angle FDE because why? Vertical angles. So what do I have with those triangles now? Can I say those are congruent?
Yeah.
Yeah, why? Well, what do I have? I have an angle. I have a side. What else? So I have two sides, Sally? I have two angles and one side. Is your side in between your two angles?
Yeah.
So what is it? I have two angles and a side.
But, I mean,
what? Angle, side, angle. So step 7, triangle BDEC is congruent to triangle FDE by angle, side, angle. If my triangles are congruent, can I now say that my sides are congruent?
Yes.
Yes. I can write my proof part. BD is congruent to FD. If I go from triangles to sides, what's that called?
HL. Just kidding.
What? The C thing. CPC. TC. Okay. Questions?
No.
There's not.